You know, choosing a home, it's one of the biggest decisions any of us will ever make. And it turns out we are definitely not alone. For animals, picking the right spot is literally a matter of life and death. But what if the way they choose is way more complicated, way more human than we ever thought? Let's follow the clues, and it all starts with a surprisingly picky mother mosquito.
Okay, so put yourself in her shoes, or her wings. You're a mother mosquito. You're flying around looking for that perfect little puddle of water to lay your eggs. This is your one shot to pass on your genes. You find a spot that looks absolutely perfect. It's got everything: clean water, plenty of nutrients for your future kids, a 5-star nursery. But then, you just fly right past it. Why? What could possibly make a perfect home completely unlivable? Well, the most obvious answer is danger, right? A smart mama mosquito knows that some pools have predators lurking in them. Take this guy, the mosquito fish. I mean, its name says it all. It absolutely loves to gobble up mosquito larvae. So rule number 1 seems pretty simple. Avoid pools with fish. It's a smart, life-saving choice. But, as we're about to find out, that is not even close to the whole story.
So let's dive into Section 1, a mosquito's risky decision. Because that simple rule, just avoid the fish, it makes perfect sense on the surface, but it doesn't explain what's really going on.
Because here's the kicker. What if that perfect pool she avoided was totally safe? What if there were no fish in it at all? Now the puzzle gets really interesting. And this is exactly the question that researchers William Resetarits Jr. and Alon Silverbush wanted to answer in this fantastic experiment.
All right, Section 2, building a mosquito neighborhood. To really get to the bottom of this, the researchers knew they couldn't just study one little part. They had to think bigger. They had to see how mosquitoes are making choices across an entire landscape. So what did they do? They literally built entire mosquito neighborhoods from scratch. Let me show you how they did it.
Okay, so first up, we have the smallest unit. They called it a patch. The easiest way to think about this is like a single house that's up for sale. It's one potential home. It could be good, could be bad.
Next, they took 3 of these patches and grouped them into what they called a locality. So if the patch is the house, the locality is the immediate neighborhood, like a little cul-de-sac with 3 houses on it.
And then, to get the big picture, they grouped 3 of those localities into an array. So the array is like the entire town or region made up of a few different neighborhoods. This whole setup lets them see if decisions are being made based on the house, the street, or the town as a whole.
And this is where the experiment gets really brilliant. They created different kinds of neighborhoods. You had the CCC type, which was like a perfect gated community, 3 totally safe pools. Then you had mixed neighborhoods, like CCF, 2 safe pools and 1 risky one with a fish. And finally, you had the CFF neighborhoods, which were mostly dangerous. This whole design was built to answer one critical question. Does your neighbor's reputation matter?
Let's move to Section 3, the bad neighborhood effect. Because what they found was just incredible. It turns out risk is contagious. So the scientists had this hypothesis they called local contagion. It's the idea that risk can kind of rub off. You know how one really rundown house can lower the property value for the entire street? It's the same idea here. A dangerous predator-filled pool, that's the red one, might make the perfectly safe pools right next to it, the blue ones, seem a whole lot less attractive.
And would you look at this? The results were crystal clear. This chart shows how many eggs were laid in the safe pools. In the all-safe neighborhoods, the safe pools were super popular, getting around 26 egg rafts. But look what happens when just one risky neighbor moves in. The number of eggs laid in those identical, perfectly safe pools plummets. The mere presence of danger next door made a good home undesirable.
I mean, the effect was so powerful, and this quote from the paper just nails it. The bad neighborhood effect on those safe pools was so strong, it was as if the fish were actually in them. Let that sink in. The perception of risk was just as powerful as the risk itself. That is wild. So let's get to Section 4, crowding into the safe zones. We now know that mosquitoes aren't just avoiding risky pools, they're avoiding entire risky neighborhoods. So that begs a huge question. If all this real estate is suddenly off limits, where is everybody going?
Well, it's just like a housing crisis, isn't it? When huge parts of the market are suddenly written off as undesirable, everyone looking for a home has to compete for the few remaining good spots. You get a massive pileup.
And you can see that crowding effect right here in the data. This chart shows the total number of eggs laid in each neighborhood type. And wow, it's not even close. The all-safe neighborhoods were absolutely swamped with eggs, almost 3 times as many as the next best option. It is a massive population boom in the good part of town.
The scientists have a really great name for this phenomenon. They call it habitat compression. It's what happens when a whole population gets squeezed into a smaller and smaller area of usable land, not because the other spots are physically gone, but because they're now seen as too risky. This is the second huge finding from this study.
So what does this all mean? Let's get into our final section, a new rule for ecology. When you put these two big ideas together, the bad neighborhood effect and habitat compression, you end up with a powerful new rule for how nature works.
And here it is, the solution to our puzzle. When an animal chooses a home, it's not just evaluating a single house. It's doing a super complex calculation based on the entire landscape. It's looking at the house, the neighbors, the neighborhood, even the whole town, all at once. The big takeaway? Context is everything.
This discovery really changes a core idea in science. You see, as the paper says, ecosystems aren't just linked by animals randomly wandering from place to place. They're linked by the active choices animals make during that journey. It's the decision-making process itself, the processes of dispersal, that truly connects the landscape. This all points to a new way of thinking that the researchers call the habitat matching perspective. It's a viewpoint that doesn't treat animals like passive pieces on a chessboard. Instead, it sees them as active, intelligent agents who are constantly evaluating their world and making choices that fundamentally shape their ecosystems.
So why does the housing choice of one mosquito matter to you and me? Well, it's a huge deal. First, it shows that a predator in one pond can affect a population in a totally different pond, maybe miles away, even if they never ever meet. Second, it means that if you destroy one little habitat, you could accidentally cause overcrowding and collapse somewhere else that seems completely unconnected. And for conservation, this is critical. It means we can't just protect little islands of nature. We have to think about and manage entire landscapes.
And really, this brings us all the way back to where we started. This whole science of spatial context doesn't just apply to mosquitoes in a pond. It applies to us. So think about it for a second. How does the context of your own neighborhood, or your workplace, or even your group of friends shape the biggest decisions that you make? It seems that whether you're a mosquito or a human, no choice is ever really made in a vacuum.